Hi guys, this is Vineet and I welcome you to this video. Today's video topic is tuning indexes using missing index suggestions in SQL Server, and this is part 3 of this video series. In our previous video, we had discussed about how you can view the missing indexes suggestions in using the dynamic management views. So in this video, we will talk about how you can view the missing index suggestions with the query store if it is enabled on your database. Before we proceed ahead, I would request all you guys to please go ahead and subscribe to my channel, especially the ones who are new to this channel and the ones who are watching my videos from quite some time but not yet subscribed to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming and future videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the videos that I will be creating on indexes in the coming 15 to 30 days. These days I'm working on the videos on SQL Server indexing particularly. So I hope this topic will get covered in next 15 to 30 days. So it's really essential that you watch out all the videos that are generated during this period, during the next 15 to 30 days. So please go ahead and subscribe right away. There's a subscribe button below this video. Click on that subscribe button and follow the process. I'm waiting, guys. Please go ahead and do subscribe to the channel right away. So guys, I hope you must have subscribed to the channel by now. Let's move on. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you want until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our video, so please do share in your comments and suggestions. Also share your stories as well. We eagerly wait for your stories and comments and would love to read the same. So do post in your comments and stories, guys. We have created some playlists for you to watch. Some of the common SQL Server playlists are database design, tables, business continuity, SQL Server indexing, performance tuning, integration services, and transact SQL. If we talk about this video pertains to the SQL Server indexing categories, which have more than 15 videos at present. And if we talk about the overall total number of videos on my channel, we have posted more than 240 videos and we are slowly reaching towards the 250 videos level mark. I will let you know once we reach that mark, and I have a channel page link as well given at the bottom of this slide. And guys, link to all these playlists and the channel link page given in the video description area. So please check out the video description area of this video. Now let's come back to today's topic, which is tuning indexes using the missing index suggestions in SQL Server. So let me take you to notes directly. So today we are talking about missing indexes, viewing missing indexes with query store. This is the topic of today, and basically let's start on it. Missing index suggestions in dynamic management views. So earlier we studied about the dynamic management views and how you can use the dynamic management views to view any missing indexes. So we are talking a little bit about that over here. So missing index suggestions in dynamic management views are cleared by events such as instant restarts. So we are talking about the SQL Server restarts or service restarts, we can say, any failovers, and setting a database offline. So if any of the events occur, like we restart the SQL Server, or any failover happen if the SQL Server is on cluster, or if we are setting a particular database offline, we lose on information of missing index suggestions in the dynamic management view. So this information gets cleared. Additionally, when the metadata for the table changes, so here we are talking about the metadata for a table. If there are any changes to a table metadata, or maybe table structure, so if there is any changes to a metadata for a table, all missing index information about the table is deleted from these dynamic management views. So it's not quite wise to keep that information in dynamic management views and always use them to obtain the missing index information, because we lose information out of DMVs by certain events such as instant restarts and failovers, and whenever we set database offline or whenever there is a change to table metadata, we lose on this information, the missing index information. Now, table metadata we were talking about. The table metadata changes, these can occur when columns are added or dropped from the table. So whenever we add a column to a table, and whenever we delete a column from a table, that result in changes to table metadata. And at that time, if we are adding or removing any column, we lose on the missing index information. And here is an example. Okay. And these are two separate items, guys. So first we are talking about whenever we add or delete a column in a table, this results in changes to the table metadata. Whenever the changes to the table metadata occurs, we lose out on the missing index information in the DMVs. Similarly, there's another example. If we are performing an alter rebuild index rebuild statement, at that time as well, we lose out on the missing index information for the table in the DMVs. Now, similarly, execution plan stored in the plan cache. So, if we talk about the execution plan or the estimated execution plan or the actual execution plan, these plans get generated, and generally they are stored in the plan cache. And these plans get cleared by events such as the instant restarts. So whenever we restart the instance of the SQL Server, we lose out on plan cache, which stores the execution plans. And whenever some failover happens if your SQL Server is running on a cluster, failover happens. If a failover happens, we lose out on that execution plan information. And whenever we are setting a database offline, we are also losing out on that information. Now, execution plans may be removed from cache as well due to memory pressure and recompilation. So whenever there is a memory pressure on the system, the SQL Server removes the plans from the plan cache, and whenever there are some recompilations, the SQL Server database engine goes ahead and removes any plan from the plan cache. So if we talk about this information about missing indexes, if they are stored in DMVs or if they are stored in plan cache, this information is not static, and it can be removed anytime by the SQL Server, right? So missing index suggestions in execution plan can be persisted across these events by using the query store, using and enabling the query store. So if we want this information to persist across sessions, then there should be a permanent place to store this information, and that permanent place is query store of a database. Now let me take you through the database properties where we enable the query store. So let's trigger SQL Server instance. So guys, first of all, I will show you where the query store is and how you can enable it on a particular database. So SQL Server is opened in the background, so let me go ahead and connect to the instance of the SQL Server. So here we are connected to the instance of the SQL Server. Here we are taking the database as AdventureWorks 2022. In my case, it's my AdventureWorks. You need to right click on the database, go to properties, and once the properties dialog box opens, expand that box, and on the left hand side there is a query store sections through which you can enable the query store. On the right hand side under the general section, we have three options. We can turn off the query store, or we should keep it to read write, and we can move it to read only as well. So ideally for normal operation it should be set to read write. So on my database, my AdventureWorks, the query store is enabled. So basically what we will show you now is we will write up a query that will retrieve top 20 query plans containing missing index request from query store based on a rough estimate of total logical reads for the query. So guys, the query that I'm writing right now will retrieve top 20 query plans containing the missing index request from the query store, and this is based on the rough estimate of total logical reads for that particular query. So even though I'm writing this query, but it may not yield anything because we have not run sufficient queries on this database, right? So query store has very little information at that time. But if it is a production database and if the queries are being triggered against that database quite frequently, query store will have a lot of information to provide you suggestion on the missing index. But for the sake of just providing you the query, I'm providing it to you here. It may not yield anything as of now, as our database is not much in use. We generally use this database for training purpose, not for the production purpose. So basically this query will pick up data that is limited to query executions within the past 48 hours. So let me write that query out for you. It will be a lengthy query, so be ready for that. Or let me write that query down and let me give you some initial script. So let's do select star from, and here we will use some DMVs for query store. So query store has its separate DMV. So first of the DMV is query store query. So let's take it as QEQ, and let's join it with the sys.queryStorePlan. Let's take it as QSP, and let's join it on the, so take this as the QSQ, query store query, and take this as query store plan QSP, and we are joining both of these dynamic management views on QSQ.queryID, QSQ.queryIT, query ID. Let's match it with QSP.queryID. So join this on the query ID column, and let's use the cross apply operator over here, and inside that so we are applying a cross apply operator over here, and within the brackets we are taking select, and we are doing a try convert. Instead of just convert, we are doing a try convert, and we are trying to convert into XML the QSP.queryPlan. So this is the statement. We are trying to convert the QSP.queryPlan into the XML format, and we are taking it as the query plan XML. So take this as query plan XML, and let's all together take it as query plan XML. Abbreviation I'm taking is QPX. So we are done here, and this was the cross apply operator which we have applied. And the next line, let's join it further with sys.queryStore runtime stats. We can take this dynamic management view where it's for query store. So let's take query runtime stats, QRS as the abbreviation, and let's join it on the query store plan ID, and let's join it with query runtime stats plan ID. Let's join it further with sys.query store runtime stats interval, and let's take the abbreviation as query store runtime stats interval, and let's join this on QRS, which is query runtime stats dot runtime stats interval ID equal to QSRSI dot runtime stats interval ID. Let's join these two views on this particular column, and here let's apply some filtering criteria using the where clause. So where I'm filtering on query store plan dot query plan, and I'm providing the like operator, and the plan should be like the missing index. Let's put that in angular bracket. Earlier I had shown you the query plan XML in the XML format. So under that plan we have missing indexes tag. So here I'm searching on that. So the plan, so it's not query ID. So it's QSP underscore query plan should contain the missing indexes tag. Let's take the last 48 hours. So I'm taking QSRSI dot start time. I'm taking is greater than equal to, and we can use the data add operation over here, and let's take hourly stats and let's do minus 48 so that it can give the stats for last 48 hours. And let's take the current system date time, and this is the function through which we can get the current time. Later on we will group this information, so for that I need to check certain columns. So let me define those columns now. Instead of using star, I don't want all the columns. So let's select top 20 queries or top 20 query plans, and the columns we want is QSQ or query store query dot query ID column I need, and then we need some functions to get some data. So here I'm using the sum function. So we will use these functions to calculate certain columns. So let's use sum of QRS which is query store runtime stats. We are working on stats here. And let's take count executions is the column. I'm taking a sum of query runtime stats count execution column. I'm taking a sum of that and multiplying that sum with average of, let's again take the query runtime stats table and take average logical IO reads. I'm taking average of average here. So this is the column we can use, average logical IO reads, and let's take this column as the EST logical reads. Now let's define the next column and we need to put a underscore. Now I'm taking next column as a, again I'm taking sum. I'm taking a sum of query runtime stats dot count executions, and this time I'm not multiplying it with anything. I'm just simply taking the sum of executions as the column. And let's take the average, and we are taking it separately now, so we want to take this separately and we are taking it as the average of average we are taking over here. So let's do average logical IO reads. Let's take average of that. And lastly I'm taking sum of QSQ or query store dot query, and we are taking the sum of count compiles as the sum of compiles. This is the fifth column, and we need some more columns as well. So let me put that out. I will run some select queries to generate a column text. So let me write that for you. In the meantime, I'm pausing this video. I will later on explain that section. So guys, I have written a code section which I have highlighted between these two code sections which I had written earlier. Now let me explain on this code section. So I'm taking some another columns. So here I'm selecting select top one row from QSQT. We are taking QSQT dot query SQL text, and QSQT is basically coming from this view which is sys.query store query text. I have taken this as abbreviation. Query store query text is the abbreviation QSQT, and I'm taking the top one columns from that particular view, query store query text. I'm taking the query SQL text, and I'm applying the where condition where the query store query text dot query text ID. I'm taking that text ID as a function. I'm taking max of QSQ, which is query store query dot query text ID. I'm taking the max row out of that particular table, and we are taking this whole thing as the column as query text of the top one query. And we are taking another column. We are doing a try convert, converting the query into XML, and we are taking the top one QSP2, which is basically sys.query store plan. I'm taking this as query store plan 2 because earlier I had taken in at the bottom the same view, and now I want to use the same view, so I need to use the different abbreviation over here. So I'm using query store plan 2 as the abbreviation for this view. I'm taking a top one query store plan, taking the query plan column, and applying the where clause where the query store plan 2 dot query ID equal to query store q dot query ID, and we are ordering this data by query store plan 2 dot plan ID in the descending order to fetch this one row, and we are taking this whole data. So this data will fetch the plan, and the try convert function will convert that plan into the XML plan, and we are taking that column as the query plan. In the first column I'm taking the text query store query text, and in the next column I'm taking the plan by converting it into the XML format. So you can write down this code, guys. If you haven't watched it properly, please watch out this video again. I've written this code partially, and then I've put in this code section. Let me squeeze the space a little bit here so that you can get the better view. So this is the overall query which you need to write to get the missing index suggestions by using the query store. Let's try to execute this query to see if it generates any missing index suggestion for us, and I think it will not generate anything because our database is not much in use. But for any of the production databases which are missing indexes, it will definitely yield out some rows. So I've executed this, but we are missing certain columns. So at the top I have taken some columns. I need to group that data now. So let me group the data. So I'm grouping it by, I want to group it by query store query dot query ID. I want to group it by, and lastly I want to group it by qsq dot query hash. And let's order this data by AST logical reads in the descending order. So whatever query has largest number of reads, it will sort according to that. So this is the complete query, and let me try to execute it. It should execute fine now. And I think we should not get any data as of now, because the query store is not much in use, as the database is not much in use. But yeah, this is the overall query, which will yield certain columns. It is yielding 7 columns, which will give you information about the queries that are executing the most and on which the indexes are required. It will give you list of those queries. Alright, so the columns here are query ID, EST logical reads, sum of executions, average of average logical IO reads, sum compiles, query text, and the query. It will give you all that. And it will only give you those query plans where we are missing on indexes, as we have taken this where clause, right? So it will only list out all those query plans where we are missing on indexes. So right now there are not much query executions, so there is not much data in the query store. That's why we are not getting anything, but otherwise this is the query you can use against your production databases to check out the indexes which are missing. But generally we want you to test the queries in test environments. So use it very carefully, although there are no updates mentioned in this query, or no deletions, no updates in this query. It's simply a select functions we are using. So yeah, ideally this query can be run against the production databases as well. But yeah, use it with care. Alright, so note it down. You can save and store it somewhere. So I can mark it with query store query for missing indexes, and you can same it using the same name, and you can run this query against the database on which you feel there are any indexes that are missing, and you want to create the indexes on that particular query or columns or on a particular table. You can check out this query. So guys, we are, I think, done with this video. So this video series will stretch to 4 parts. In the next part we will talk about how you can apply the missing index suggestions if it is given by any mechanisms like the estimated query plans or the DMVs or the query store plan views. So if any of the mechanism is giving you information about any missing indexes, then yeah, we will talk about how you can apply the missing index suggestions, how to use those missing index suggestions. And most probably we will use the estimated execution plans, because the DMVs have not yielded us any data, and also the query store queries not yielded us any data. So we will try to use the estimated execution plan to review how you can apply the missing index suggestions. So guys, I thank you so much for your time on this video. I hope you like the content of this video. If you really like the content of this video, please hit on the like button below this video. And guys, if you are new to this channel, or if you haven't yet subscribed to the channel, I would highly recommend, please go ahead and do so right away. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon and select all notifications to get notifications regarding all my future videos and upcoming videos. The reason I'm asking you to subscribe is because I will be releasing many more videos on indexing topic in the coming 15 to 30 days. So I don't want you to miss any one of these videos. That's the reason I'm asking you to subscribe. So please go ahead and subscribe right away. There's a subscribe button below this video. Click on that subscribe button and follow the process. I'm giving you 5 seconds so that you can go ahead and do that. I'm waiting. So guys, I hope you must have subscribed by now. And if you have subscribed, possibly if you are new to this channel, or if you are an older user who have not yet subscribed to the channel, please go ahead and do so. And I hope you have subscribed to my channel by now. And guys, do post in your comments, suggestions, and any of the stories, any of your day-to-day stories with SQL Server. You can post it to us, and we eagerly wait for your stories and comments and would love to read the same. Also guys, if you have a good network of friends who are also working in SQL Server domain, you may share my videos with them. There's a share button below each and every video. through which you can share my videos on any of the social media platforms with your friends. And also you may also ask your friends to subscribe to my channel in case you feel my videos can make difference in their life. If you feel the same, then yeah, you can ask your friends to subscribe to my channel. That is the help I required from your end. And guys, I thank you so much for your time on this video today, and you have a wonderful day ahead.